Okay, this is the tricky one. 2 times 3 to the power of x equals 6 to the power of x plus 1. So there are a couple traps that people get sucked into, and I'm just going to point them out as we go through it. The first one is that everybody wants to just multiply. 2 times 3 is 6, and then, hey, look at this. We got the same base on both sides. We can just get rid of the bases and solve for the exponents. It doesn't work because of BEDMAS. According to BEDMAS, you have to deal with exponents before you can multiply. So if I don't know what that x is, that 3 is raised to, I cannot multiply by 2. I need to multiply 3 out. So say it's 3 to the power of 3. I got to go 3 times 3 times 3 and then times 2. So if I don't know what that exponent is, I cannot multiply the 2 in. Okay, so scrap this. The only thing to do really is to take the log of both sides then. So I take the log of the left, log of the right. Second common mistake is that, okay, we're going to take logs right away, but then they want to roll that x down on the 2 times 3 to the power of x. I can't roll the x down because 2 isn't raised to that power. That power is only for the 3. So the only way that that exponent x can be rolled down is that we got to separate the log 2 and the log 3. So because it's 2 times 3, this is the same as log xy equals log x plus log y. So we got to use that rule to split them apart. Then we can roll the x down. On the 6 to the power of x plus 1, we can roll that exponent down because 6 is by itself. All right, so break it up so it becomes log 2 plus log 3 to the power of x equals, I'm going to roll down the x plus 1, so I'm going to get x plus 1 times log 6. Now I'm going to roll down the x that's attached to the log 3, and I'm going to expand the x plus 1, both of those times log 6. So it's going to be log 2 plus x log 3 equals x log 6 plus log 6. At this point, I got to group my x's together on one side of the equation and the log 2 and the log 6 on the other side. So I'm going to get the x log 3 and the x log 6 on the left. So it's going to be x log 3 minus x log 6. And then the terms without x's on the right. So it'll be log 6 minus log 2. Now that the x's together on the left-hand side, I can factor out an x. So it's x times log 3 minus log 6 equals log 6 minus log 2. And last step, I got to divide both sides by log 3 minus log 6. Okay, on the left, it's going to cancel out. On the right, we need to now enter this into a calculator. You could actually simplify that a little more if you want to, but typically it's not done. What's really important is that you put brackets around the numerator and brackets around the denominator. So when I enter it into the calculator, or into Desmos in this case, it's just log 6 minus log 2 inside brackets, all divided by log 3 minus log 6. So what the brackets make sure is that it's the whole thing in the numerator, the whole thing in the denominator. If you don't have brackets, it's really only going to divide the log 2 by the log 3. And there's the solution, negative 1.585. Just to check, I'm going to graph this from the original. So I'm going to graph 2 times 3 to the power of x minus 6 to the power of x plus 1 and see what the 0 is. And there is the 0, negative 1.585. So I get the same solution both ways. So x equals negative 1.585.